All right, hi everybody. It is Miss Power. This is Tuesday for AP Stats. And I wanted to go through a little bit of the techniques possibly for doing our online AP testing this year. One of the rules is that you're allowed to have as many devices as you want, but they're very specific about wherever you receive the question is where you have to upload your answer to. So you are welcome to either handwrite your answers or type up your answers, and they're going to be really flexible about special symbols and stuff that you can just use the names of the special symbols instead of trying to go find them, or you can go find them, it's up to you, or you can handwrite it. The problem is at the end of every question, you're only going to have 5 minutes to make sure that you upload it back to AP College Board in the same device that sent you the question. So if I'm using my laptop, which would be my preferred way to get a question because the screen is bigger, it's easier to set up, I can prop it up better. But I want to do all of my writing maybe on my iPad using my Apple Pencil or something like that. I'm going to have a problem of how the heck do I get it back to my main laptop. So for me, that would be probably to email it to myself, wait for the email server to load it in, download it onto my laptop, and then upload it from my laptop. So I'm trying a few other ways of maybe looking at some other options for that. So today I thought I would try going through our linear regression problem by doing everything on my laptop. Now I don't know how well this is going to work, and we'll give it a try. Okay, but I thought let's give it a try with actually using just my entire laptop. So what I'm going to be doing here is I've split my screen, and all that means is I've, instead of use the big button, I'm using the little arrow or the little double box buttons in your upper right hand side. And I have the left side of my screen is going to be my question, and the right side of my screen I've opened up just a Google Doc, and that's going to be where I put in all of my answers. So as I start looking at some of this stuff, hopefully here, I believe. Yep. Okay, so we should be seeing on the left side is the question we're going to go over. On the right side is my Google Doc. And I'm going to pause versus going and recording all this and then finding out later that this isn't visible. I'm going to go pause this for a second and just make sure that I am doing this correctly and that I can actually see both of these. So you're going to see a little bit of a pause in here for a second so that I can go double check that. So yay, your fearless leader, it looks like she might have actually set this up correctly. Good, okay. So here we go. So you have this one on the Google Classroom. You can download it and follow along with me, pause your screen and just give it a try, see if you can get it set up kind of the same way I have. Okay, so the first part is just our quick review here about things that you should know. Again, if I can't get to some of these words as quickly as possible, I put them in some of them in parentheses. So like down here, right here, I've said that if you can't write Y hat, just write Y hat, and that's totally acceptable to them. Okay, so there's stuff like that that we can do. So I'm gonna assume they're not going to give you raw data because your calculator is not required this year on the AP exam. So my guess is that they might give you the original scatter plot, and they might give you a computer printout, but they're going to give you a computer printout. They're not going to have people doing stuff by hand. They're going to give you the summary information. Everything else is just for you to look at for trends or for outliers or stuff like that. But I think if they give you a question that's going to involve linear regression, they're going to give you one of these printouts. Okay, so remember that the key idea here is that I don't need any of the stuff at the bottom unless I was doing tests and stuff, which this is not part of the test. This is one of the units they took out. So like our probability number down here would have been our p-value and stuff like that. We're not going to have to do any of that. Okay, so the most they're going to ask us about is this top portion up here, which remember has a constant and then some kind of word that relates to the problem. Okay, so this is going to be the study concerning the relationship between the average amount of time spent outside per month, and that's in hours, and the population of a city X, that's in millions, results in the following mini-tab output. Okay, so it says part A, what is the equation of the least squares regression line? Okay, so over on this side, I'm going to type in A, and I'm going to say, what is the equation of a least squares regression line, right? Well, it would have been y hat. So instead of me bringing up like some kind of math editor or anything else, I'm just going to type in the word y hat. And if you forget the little accent in between or whatever, and you just called it y hat, I'm sure they're still going to take that because they understand that some people are going to be using their keyboard, some people are going to be writing, some people are going to be very good at using their math notation stuff. So I'm just going to say y hat equals, and then I remember that it is a plus bx. Okay, so that's some version of that. And that in our case, I know that that is going to be not y hat. What is the y values? Well, the y values is time spent outside per month. So I'm going to be calling that where y hat equals time spent outside per month in hours, and X is going to be equal to the city population in millions. Okay, so back to my equation, I'm going to have y hat equals, and remember when they write it to us, that first column down, 17 and then the -6, are the order you put in your a plus bx. Now, if you have your calculator next to you and you went and you tried to do a linear regression, it would actually show you that that's the format that it would give it to you in, same format when they give you the printout. So I'm going to write y hat equals 17.15 plus, in this case it's going to be a minus, 6.650x. Okay, so there's my equation of my least squares regression line. You always identify your variables, and in every single AP question, you always identify every variable that you are using in context. Never should you have an equation that's just talking about x and y. Always you are talking about it in terms of context back to the problem. So in this case, we're going to be talking a lot about hours spent outside per month and about populations in millions. Okay. All right, so next one, on to part B. Now, I'm not going to worry about format too much. If it doesn't line up, I don't care. My goal is to get my question done as fast as possible. So practice a little bit using your computer to type versus using your keyboard or your iPad to write. See which one works better for you. We'll do some timing, and I know the AP board is going to give us a practice of uploading stuff to them to make sure that they can get it and that you feel confident that 5 minutes is enough time to do that. Okay, next one, it says estimate the mean amount of time spent outside for a city having a population of 1 million. So what they're telling us in this one is they want me to put in 1 million. So looking at my answer for part A, 1 million is the x value. So they're asking me to do x equals 1. I'm not going to put in 1 with a whole bunch of zeros. X is already done in millions. Okay, so I'm going to put in an x equals 1. So that means I'm going to get y hat equals 17.17 minus 6.650 times 1. Now from here on in, I'm going to grab my calculator off the screen and I'm going to go calculate that. And I'm going to get that my answer is y hat equals 10.5, and then I'm going to give it back to them in hours and in context, okay? So that means they said estimate the mean time of time spent outside is the mean time spent outside per is the mean hours time spent outside per month for 1 million population, or for a city of 1 million. Okay, so that looks like a decent answer for B. Going on to C, it says determine the proportion of the observed variation in time spent outside that can be attributed to the population of a city. All right, what the heck does that mean? All right, so for this one, we are looking at, I guess I didn't want tabs, darn it. There we go. So for this one, we are looking at the keywords of what the heck do they want from us. Okay, it says determine the proportion of the observed variation in the time that can be attributed to a population. So this is our R squared value. Basically, they're asking us to do R squared. So R squared has a very specific formula sentence that we always do. So we're going to turn this into finding out what R squared is. And if I go underneath coefficient, I see 84.4 and then next to it 83.3. We're always going to take the 84.4%. Okay, so I'm going to say that as, here is the official sentence, 84.4% of the variation in mean hours spent outdoors per month can be explained by, sound familiar, the linear relationship between our x and our y, between the city population, and I'm going to again say in millions, and the mean hours spent outdoors per month. Done. Okay, that is our official sentence. Is it always has the percentage of the variation, and then it's the percentage of the variation of y's, so that's the mean hours spent outside. We have to say that it's explained by a linear relationship, so something about that makes a linear relationship. And then we repeat what the linear relationship is between, so between the x's and the y's. Okay, all right, so on to part D. So part D, our extra stuff that I added in, okay, this is every possible question I can think of where they ask you to just see if you know what the vocab is and how to describe the vocab, okay? So the next one is describe the slope of the regression line. So I know that slope is the next number that I use before the x. So that's going to be the negative 6.650, and I'm going to put it over 1 just to remind myself, okay? And the reason I remind myself is that it's y's over x's. So we always start with a increase of 1 in the x. Even if it's negative, I'm going to say for every time that the x goes up by 1, that's the one on the bottom, the y will do this. And the y is the number on the top. So since y is negative, I'll say the y's will go down by this. Okay, so I say for every increase of 1 in the x, which is million of population in a city, what was the y value? The y value was the mean hours, right? The mean hours of time spent outdoors per week decreases, because it's negative, by about 6.650. So what was the y value? What was the units for that? So that was hours. Okay, so every time the city population goes up by 1 million, we can expect that that city will spend about 6.6 hours per month less outdoors. Okay, so that is our description. Notice everything is coming back and talking about city population and talking about hours outdoors. Never do you leave those two words off when you're describing things. Everything's in context. Okay. All right, next one is find the residual value for a population of 3 million that spent 2 hours outdoors. Okay, my big word here is they're talking about a residual value, and I know that a residual value is y minus y hat at that same x. So at x equals, what was the x that they wanted? 3 million. Okay, so I'm going to have to go figure out what y is at 3 million and what y hat is at 3 million. They gave me one of them in the problem, okay? They gave me y equals 2. So I need to use the formula that we just provided to figure out what y hat is. Okay, so I'm going to do y hat equals y hat equals, and I'm going to say y hat equals 17.17 minus 6.650, and this time we are multiplying it by 3. And when I do that, I get a y hat equal to, and I'm just going to go grab my calculator and calculate that out. And I'm getting a negative 2.8 hours. Okay, so next is I want to do the residual. So I'm going to do the residual is y minus y hat. So the y was 2. So 2 minus negative 2.8, which is going to be a positive 4.8. And since it is a y, it is hours. So what does that mean? It means that the distance between those two y's is about 4.8. Okay, and I want to be able to say positive. So why would I be saying positive? Well, which one was higher? We had that the original y was at 2, but the best fit line would have put it down in a negative number. So we are basically saying that our data point is higher than the estimated, that's what hat means, the estimation of y at x equals 3 million. Okay, I could reverse that, but now my numbers won't match, as I could say that my estimated y is lower than the actual point by 4.8. Okay, that's an acceptable way as well. I'm just using the words that matches the positive. Okay. All right, on to F. What is the correlation coefficient and explain it in context? Okay, so they're using a vocab word just to see if I know it, right? They're going to ask you just enough so that you really don't have time to go and Google answers. Their other option is they're going to ask you critical reasoning questions to explain why things happen that you can't just go Google. Okay, so it's less likely it's going to be entirely about just vocab stuff. They might ask you some to get you some easy points to begin with. That's what we're doing, is we're making sure you know where all the easy points are. But then they might actually ask you to reason out some stuff and answer some questions that require you to just think about what the numbers are saying. Okay, so in F, correlation coefficient, that's the letter R equals. Okay, so they want me to find R equals. Now, normally I would have done this in linear regression on my calculator, but I'm not creating the linear regression equation. They gave it to me. So somewhere in that table is R. Now, it's not listed anywhere in here. I have to know it comes from R squared. Okay, so R is going to be equal to the square root of 0.844. So I'm going to go grab my calculator and go figure that out, and it's going to be R equals 0.919. Now here's the problem, is R squared is always going to be positive. I have to figure out, is it plus or minus? Okay, so is it going to be plus or minus? How do I determine that? Well, I'm going to go back and I'm going to look at the slope number. And if the slope was downhill, it means my best fit line was downhill. That means that my correlation number should also be downhill. So I'm going to go ahead and put in a negative amount so that it matches the slope. Okay. If I went the other way, if they gave me R and I was trying to figure out R squared, it wouldn't matter, because if R was positive or negative and I squared it, it will become positive. Okay, so it's only when we go backwards from a squared to a square root that I have to remember about pluses or minuses. Okay, so back to the question of F, it says, explain what this is in context, and is it positive or negative? So we think it's negative. Okay, so what is the definition of R? R is the one that just tells us how good the line is, right? Like, is it a good line? Is it a strong line? Is it a not strong line? So a 0.9 is a really strong line, right? Now, I don't have the original scatter plot to see if the dots look like they're in a line. So the only thing I can really say is that the correlation number tells me that it is, what could I say? That the linear relationship, between, again, I want to include context, right? Between hours spent outside per month, and what was the other thing? The city population have a strong negative association or relationship between each other. And what does that mean? That means that as city population increases, the hours outside decreases because it's negative. Because R is negative. Okay, and I don't think they'd be looking for this, but this is assuming that the scatter plot appears to have a linear relationship, right? I can't really tell if it's really a linear relationship or not without actually looking at the dots and saying, yeah, it looks like they're pretty much in a straight line. Okay, all right, G. What is the y-intercept and how does it apply? So you find the y-intercept by plugging in x equals 0. Okay, so back to my equation. If I plug in x equals 0, I'm going to have y hat equals 17.15 minus 6.650 times 0, which would eliminate that, and I would just have y hat equals 17.15. Okay, so y is hours spent outside. Okay, so the second part of this says, how does it apply? Okay, so what does it mean when we have no time, no population? Well, they're saying that the relationship between those two is if you have no population, the average time spent outside per month is 17 hours. That's dumb. If you have no population at all, the average time the population spends outside is. There is no population to spend outside. So I still want to show them that relationship, but I also want to comment on how that's ridiculous and doesn't make any sense. Okay, so I would say if the city population is 0, the predicted, estimated, anything like that, the predicted hours spent outside is approximately 17.15 hours per month. This is silly because there is no population to spend time outside. Okay, so we kind of just say that it seems a little bit silly to even ask this question. Okay, sometimes it'll be negative, and then you're like, how do you spend negative time outside? Sometimes it'll actually make sense. If we have none of this, then we would have this much of a, cost value or something like that. So they're looking for you to describe, is it reasonable or not? Do these numbers make sense? All right, on to H. What is the estimated time spent outside for a city with, look at all those zeros. Okay, so here the key thing is they are seeing if I understand that the X's are in millions of people. Right? So they are giving me X is 1.5 million. So I have to remember when I plug in the formula, I'm not putting in all those zeros, I'm putting in 1.5 because the formula already accepts millions. Okay, so they want me to find y hat for that. Okay, so y hat equals 17.15 minus 6.650 times 1.5. And I go and I find that out and I get y hat equals, and this time I'm getting 7.175 hours outside per month. Okay, and I'm going to say estimated hours. So I'm going to go back and say estimated hours outside per month. Good. All right. So next one is I. If when collecting or sampling data for cities, the range of populations recorded varied from. So see, it would have been nice if I would have had the scatter plot. I could have looked at the x-axis and said, oh, these numbers go from 0.4 to 6. Right? And they're asking, is it okay for me to use 1.5? So basically what they're asking is, are they asking me to estimate numbers within the numbers that I collected? So since that the X values ranged between, in millions, it'd be 0.4 to 6 million people, it's reasonable to use the best fit line equation to estimate 1.5 million people and the hours spent outside, right? Because it's between them. So I want to say that because 1.5 million is within the collected data's range. Okay, but then they asked, what about 11 million? 11 million would not be an appropriate use of the equation of best fit. Why? Because 11 million is outside of the range of populations collected and would be extrapolation. And remember, we know that extrapolation is bad, okay? So if we don't collect it, we don't want to estimate outside of it, okay? All right, and then part J would be, what is the explanatory and response variable? Way to bury the easy question here. So explanatory is just the x, right? Explanatory is just the x. So the explanatory variable is the millions of people within the city, and the response variable is the hours spent outside per month. Notice I'm not spending a lot of time going back and fixing typos, okay? If they can understand what it says, I'm good to go. If I have time at the end to reread my stuff, maybe I go fix it then. But really, if this was an AP, I'm not going to go back and fix minor typos. If they can understand it, it's going to stay right where it is, okay? All right, next one, K. As a statistician, would you rather use data that has an R of 0.99, an R of negative 0.99, or an R of 0, and why? What values for R would be impossible? Okay, so this is just checking if I understand what R variables are. Remember that the closer an R value is to 1 or negative 1, the better those data points are falling directly within a line, right? So a 0 means they're just a hot mess of clouds of dots that I can't really see a best fit line to even go through. So I would rather have either a plus 0.99 or a negative 0.99. I don't have a preference between those two, okay? So I would prefer R values closest to R equals plus or minus 1, because that would tell me that the linear fit of the data points is as strong as possible. And R value equals to 0 doesn't tell me that the data points are a good fit with the best fit line. Okay, and then the second question, R values. So R values that don't work, that are impossible, are any R value more than 1 or less than negative 1 are impossible. Okay? So they just want to see if you know that. All right, on to L. What would you describe the S value given in the output? Okay, S value. Let's go back up to the thing, see if we can find an S value. There it is. It's 5.454. So we're going to write S equals 5.454. Okay, bring that back down. And L says, how would you describe the S value given in the output? Okay, so S value is some kind of standard deviation. In this case, we're going to call it, it is the standard deviation for the residuals of the best fit line. And again, best fit line, least squares regression line, LSRL, any of those are fine when you're talking about the line. They're all kind of interchangeable words. You should not lose any points no matter how you call that best fit line, okay? So it is the standard deviation for the residuals. Okay, so what does that mean? Because they still want you to describe it, right? Okay, so how would you describe the S value? So what does that mean? Okay, so that means that every time the least squares regression line is used to estimate a Y. So what was Y standing for? Y was the hours outside. Used to estimate the hours spent outside per month. Our estimate will be off by an average of 5 point, what was that number again? 5.454. Okay, so meaning, doesn't mean every time I use it, it's going to be off by 5, but it could be off by an average of 5, a little bit more than 5 one time, a little bit more less than 5 another time. So if you're asking me to make an estimate that I think is within 1 hour, this is not the best fit line or the best fit data to do that. I'd have to say I can't. The best estimates that I'm giving you off of this line are going to have an error of about 5.4 hours. All right, so let's keep going. Okay, now I wrote down every possible question I could think of, so these are kind of getting long. All right, let's go on to M. All right, so it says if the residual plot showed a definite parabolic pattern, what would you conclude? So remember, residuals that show patterns tell us that the original dots were probably not best represented by a least fit. Okay, so we have the best fit line is probably not the best thing. Okay, so the best fit line is not the best representation of the data. Okay, in other words, the original data points, and I have not used context again, so I'm going to bring it in here. So the original data points, plotting population, city population, and average time spent outdoors may not be a linear relationship. Okay, this is why it's so important that we be able to see the original scatter plot, because we would have already had a guess about this if we saw the dots were making some kind of weird U shape or an exponential where they went uphill really fast but flattened on the other side, or they went downhill really fast but flattened on the other side, something like that. Okay, so we don't have that, so we have to just take the table and keep saying, boy, it would be nice to be able to see the scatter plot. Okay, but this would be one of the times where I'd have to say, hey, this is not going to be a good fit if my residual is making some kind of parabolic pattern. Okay, I don't have to make a guess of what I think the original pattern is based on the residual. I just have to say the one we chose to use is not a good fit. All right. All right, so now I started adding in some more stuff, and this is the new section. Okay, so it says, let's assume that the data was better represented by taking the same values of x and the natural log of y. Okay, so had we completed the required units, they would have had us do testing and confidence intervals on slope of a best fit line. But we also would have talked about how could we fix that best fit line if that scatter plot wasn't linear. Okay, and if you had the raw data, we would have shown you how you can try to unbend things and what things you could do. Again, on the AP, I can't imagine with the time left that this is going to be one of their primary things, but I'd rather we go over it than just hope it doesn't exist. Okay, so they might actually tell you that they have already changed an x or a y variable in an effort to try to linearize it. Okay, so they think that the y's were doing something that was way more extreme than the x's. So they kind of flattened it by bringing in an ln. Okay, so I don't need to worry about what the original looked like. I just have to know that they're telling us this is the line that made the best fit. Now notice it's not y hat equals anymore. It's ln of y hat equals now. And that's fine. It just means that now every time I talk about that y variable, I have to talk about it as an ln of the y variable. So you are never allowed to just talk about y without talking about ln of y. And if they were going to put it up in the original data point, they would actually say it right here up top in their description. They would say ln of y, they would say log of x, they would say e to the x, they would say x squared, whatever it is, they would put it up here. And then if possible, they might even put it in here and call it like ln here, but really it's up here that you're looking for. So the key thing is the second they change the x or the y, remember how every problem I'm trying to do context, right? Is that now every time I talk about the y, I'm going to remember to put in ln of y. Even if I have to go and search it at the end before I turn it in and upload it, every time I talk about y, I'm going to talk about ln of y. Really, that's the key thing that you need to know of the new stuff that we had not gotten over because it was in that last section, okay? So most of the last section that should not even be seen on your test, but this part is questionable about where it falls within our textbook. It falls within 12.2. But according to the College Board, it would be in one of the earlier units. So it could potentially show up. I really doubt it, but I'd rather you actually see it and practice it a couple times than just not see it at all. Okay, definitely not a humongous thing. Way more important to understand how best fit lines work. Okay, so let's go back to N now. Okay, so it says, how would the correlation coefficient change from the transformation? Well, R values, remember R value was equal to negative 0.919, okay? That does not have units to it. It was just something that would show up. So R value should not change because it doesn't involve units. It's not about hours outdoor over something else where it'd suddenly be ln of hours outdoor, right? Because R doesn't include units. Okay? All right, what about O? So O says, how would you explain the slope in this context? So again, I'm going to say that slope is still equal to negative 6.650 over 1, except now the units have changed, right? So again, I'm going to say for every increase of 1 million in the city population, because that was the X, that does not have the line or the ln on it, city population, the estimated hours spent outdoors per month decreases because it's negative, decreases by an ln of 6.650. Done. It just, every time you talk about a y now, it's got ln in front of it. That's it. Not really a humongous deal. Okay. What is the y-intercept of the transformed equation? Explain it in context. Okay, so if x equals 0, then we would have had ln of y hat equals 17.17 minus 6.650 times 0, which would have been ln of y hat equals 17.15, right? And this is, explain this in context, okay? So again, I could say when the city population is 0, the estimated time spent outdoors is ln. The estimated ln of time spent outdoors. The estimated ln of time spent outdoors is 17.15. Ln of time spent outdoors is 17.15. Okay, so now it's ln equals. Okay, and really that's all they're looking for. Now, I could be all mathy about this, and if we had all the time in the world, we would be, okay? So here's basically the other way that you could say this, is if I had ln of y hat equals, how do I get rid of an ln? Well, I'd bring an e into those sides. So I'd be saying e raised to the, where's my little caret button? There it is. Raised to the ln of y hat equals e, caret button, 17.15. And the E and the ln on this side would cancel out, and I just get y hat equals. And on the other side, I would now have grab my calculator and do E, which is above ln, to the 17.15 power, and it would end up being, get this, 2806405.24. Putting in commas like this matters. 28 million hours per month. I don't even know, is that enough hours in a month? Do we even get there? So if there's 24 hours in a day and you multiply it by 31 months, we would only get to 744. So now it's absolutely ridiculous, right? But again, you could just say it seems really unlikely that a city with nobody in it would be counting how much average time they're spending outside, okay? So explain it in context. So explaining this one in context, we would be saying something like, it's still ridiculous, right? So we'd be saying that if a city had 0 population, there shouldn't be an average or mean hours spent outdoors by the population. Okay, now that would be enough. I don't need to have calculated for y hat to say that it still is ridiculous that the numbers go up. Just who cares, right? So something along those lines. All right, I'm going to move on. All right, the last one, Q. Okay, it says if the R had changed and is now 0.92 on the transformed data, is that enough to determine that the transformation is a better fit for these data? Explain. So what are they really looking for here? Is they're basically saying, forget all the other stuff. If I just gave you an R value that was 92 instead of the, what was it before? Yeah, it was like a 0.91 anyway. So they're basically saying if the R value was about the same, is that enough to determine that the transformation is a better fit? Well, remember that in order to determine if a transformation is a better fit, we would really want to look at not only did the R value increase, but did the residual plot now no longer have a pattern to it. Okay, so the biggest thing here is not that the R value, whatever the R value is, right? It's really when I looked at the original, it didn't look linear. Now that I've transformed it, the residual no longer has a pattern. Now it's a better fit, okay? All right, so our last one would be something about, no, in order to determine that a transformation is truly better, we would need to see that the residual plot no longer has an obvious pattern to it. Okay, so as I'm finishing this last question, it's occurring to me that back up in N, I probably should have come up with something else about the question for N that says, how would the correlation change from the transformation? So the correlation number itself could change, the units wouldn't have changed. So I think for next time, I would definitely insert over here and say something about how would the units change, and say, so I'm going to say R equals blah, blah, blah. The units should not change because R doesn't include units. Okay, that's not exactly what the question asks now, but I made it up, so I'm telling you that for me, I think I want to say that yes, for sure, when you transform data, the correlation number sometimes gets better or worse and suddenly says you're better, it's a better match. But they really want to test to see if you know that R doesn't include units. Okay, so I'm going to go up here and say that is my mistake. Go and change that to say, instead of how would the correlation change, how would the units on the correlation change? And the units would not change at all because there are no units. Okay, all right, so if I transform something and the R gets better, that's an idea, but it's not good enough unless both things happen, that I also see that the residual plot now does not have an obvious parabolic pattern to it. Okay, that's about every question I can think of that has to do with linear regression stuff, okay? So the last one was we had a way, and this is back to old review stuff for number 3. Okay, so this is for problem number 3. All right, so the last thing was, could you come up with slope and y-intercept on your own if you had to, if you weren't given the data plots, if you, again, didn't have them put into your calculator under list 1 and list 2. So it says find the slope and the y-intercept of the least squares regression line, then write the equation in context. Okay, so they are giving me a point that must go through the least squares regression line, okay? So first thing that I know for number 3 is that x bar and y bar are a coordinate point on the line. Okay, so I have a point. I don't have the slope, so that's where I'm going to start. So the slope, and I believe this is on our formula sheet, slope is going to be equal to r times standard deviation of y over standard deviation of x. Okay, just like slope is usually the change in y over the change in x, this is standard deviation, which is the approximate error of y over x. We just need to multiply it by r. So in our case, this is going to be 0.84, and standard deviation of y was 10.60, and of x is 2.71. I'm going to grab my calculator, put all those numbers together, and I'm going to get a slope of 3.286. Okay, so there's my slope. All right. Next thing is I want to plug it in, right? So remember that our formula is y hat equals a plus bx. So slope was b. Okay, so we now just found out that this number right here is going to be 3.286. So the last thing that I'm missing is the a, and I can find that by putting in my y and my x of the points in for y and x here. Okay, so this is just to help me solve for the last part. So I'm going to go and put in the y bar amount, which is 171.43 equals a plus 3.286 times, and the x bar amount is 24.76. Then I'm just going to use algebra to solve for a. So I'm going to have 171.43 minus the quantity 3.286 times 24.76 equals a. So when I do that, I get that a equals, hopefully I did this right, negative 642.184. Okay, so now I'm going to go back into my equation, which is y hat equals, the a is negative 642.184 plus 3.286x, not in context yet. So either I have to identify those variables or I have to put it in. So I could say that the predicted, what was y representing? It says that the teacher thinks that she can predict a student's height from their foot length. So that means that the x's are their foot length and the student's height. So the predicted student height, and that's in centimeters, is equal to negative 642.184 plus 3.286 times the foot length in centimeters. Okay, so again, my choices are at the beginning of this entire thing, I just said what y and x were up here. And then down here, I showed you another way where the equation just has it directly in it, and it says predicted student height in centimeters equals. Cool. And I think that's all they're looking for there. All right. So work hard this week. We will talk to you on Thursday for any questions that you have about linear regression and about two-way data. And I think there's some other stuff in there about one-way data, practicing SOCs, and describing how a graph looks. And we'll go over any questions that you have for Thursday as well. There are 2 FRQs. Make sure you write those up nicely because there might be another trade happening there for peer review. So it is important that you get these in on time, people, so that I can give you points for the continuing stuff. I can't trade your paper if you don't turn it in, so you lose out on the points of grading somebody else's as well if nobody can grade yours. Okay, so we'll talk to you on Thursday. I know this was really long. I apologize. Must be because I miss you guys so much. All right, we'll talk to you soon. All right, bye.